Greetings to everyone. My name is Aravind, son of Subramaniam. I'm a UTeM student who's studying Bachelor of Computer Science, major in Artificial Intelligence. Today, I will present my innovation project titled Predictive Maintenance Using Deep Reinforcement Learning under the category of AI and Machine Learning. To introduce my project, this project focuses on developing predictive maintenance solution using deep reinforcement learning to produce an optimal maintenance policy for machines. With sensor data from a machine, the deep reinforcement learning model can learn to predict the maintenance before the failure, as deep reinforcement learning works well with complex patterns and adapt to fast changes. So the objectives of this project are to develop the optimal maintenance policy for industry machines with the aid of deep reinforcement learning algorithm. Second is to predict and prevent machine failures by scheduling maintenance before the failure. Third is to reduce unnecessary maintenance and repairs by performing maintenance at the right time. For methodology of this project, it follows the CRISP-DM methodology, which consists of 6 steps. First is business understanding, where the business understanding for this project is to develop predictive maintenance model using deep reinforcement learning. Data understanding is we use NASA CMAP turbofan engine dataset, which is a multivariate time series dataset, and it is also a synthetic dataset generated by NASA. So for data preparation, we perform data cleaning and also we normalize the data to have the specified range of data, which is useful for the training of the model. After that, we split the data into two sets, which is training set and testing set. So next we move on to the modeling part. So in the modeling part, we have prepared reinforcement learning environment, and also we have deep Q learning algorithm implemented in this step. And also we have combined several models such as deep learning model within the deep Q learning algorithm to develop a predictive model for this project. So this combination of models also have undergone fine-tuning process to give a better performance for predictive maintenance domain. So for the evaluation, we have evaluated the performance of this model by using a loss curve and also a policy graph. So for the deployment stage, the model with the best performance is deployed. So let us move on to result and analysis section. So here I presented loss versus epoch graph using deep reinforcement learning based model. The training loss curve shows the good learning with decreasing loss mean squared error value over epoch trend. Initially, the loss value is high when the epoch is 0, but over the time, as the model starts to learn, the loss value decreases and also it reaches convergence point. This indicates a good learning curve. So next, I presented policy graph over here. So the testing results show that the deep reinforcement learning based model can predict optimal maintenance for most units in the testing phase, which is 20 to 50 cycles before failure occurs. So as we observe this graph, the red color highlighted lines are failure states, blue color are the predicted replay state by the model, and this gray shading indicates the optimal maintenance that the model can take. So as we can see, the blue color lines are lies on the gray color shading. This indicates that this model can predict the maintenance optimally for this domain. So let us look at the novelty and inventiveness of this project. First, this is a new approach for predictive maintenance. Deep reinforcement learning is something new for predictive maintenance, where previously predictive maintenance is done by deep learning methods, supervised learning, and also data analytics methods such as anomaly detection techniques. Second, adaptive maintenance decision making. When a new data arrives, deep reinforcement learning can adapt to the new changes and make the maintenance decision according to the new data and also considering the historical data. Third one, innovative learning method, where deep reinforcement learning is something new, and it's an innovative learning method where it can learn so much information from the complex data set. This is very, very useful for manufacturing industry nowadays. Fourth is maintenance policy optimization. Deep reinforcement learning have the capability for optimizing the maintenance policy based on the understanding of the data. Let us look at the potential of commercialization of this project. Firstly, it is an advanced maintenance strategy where deep reinforcement learning based model it can produce optimal maintenance policy where the previous methods cannot. Second, market demand for optimal maintenance policy in the industry is very high since deep reinforcement learning able to produce optimal maintenance policy. So this is a very potential for commercialization in the industries, especially in manufacturing. Third, deep reinforcement learning based predictive maintenance solution is scalable to many industries, not only for manufacturing. It can also expand it to automotive and also aerospace industries. Last but not least, it is a cost-effective and profitable solution. So since we are preventing failures, machine failure from occur, this is a very cost-effective solution. And also we can gain profit from preventing the machine from fail and also performing the maintenance at the right time. So I guess that's all from me. Thank you very much for listening.